So I'm going to talk today about a student-led project to take the RNAMake toolkit and create a gateway environment from that. As Lauren said, this slide was created by myself and Derek. Derek is presenting later in the week, so I told him I would take over this presentation to reduce his load during the all-hands meeting. Real quick introduction of myself. Many of you know me. I spent much of my early career with Open Science Grid and working with them intimately. However, since then I've moved on and I'm currently the Associate Director at the Cyberinfrastructure Integration Research Center at Indiana University. All those words basically mean help in integrating researchers with various different cyber infrastructure. I also am part of the XCEED project and manage the Gateways consulting group within XCEED. So getting started, no, maybe not getting started. Let me try this again. Okay. There we go. So getting started, I want to say, first of all, this was a project that brought together the science and a toolkit developed at the University of Nebraska with some undergraduate students in computer science, computer engineering, and software engineering, and then brought them together with the various different infrastructure. And by infrastructure here, primarily, I mean the Open Science Grid and Apache Airavata, which is a gateways framework, but it also included some infrastructure that was put forth by XCEED with the extended collaborative support services, basically a group of consultants, and also the Jetstream 2 project, which hosts the gateways in the development environment. So really, it's about bringing all three of these groups, the science group with a application and toolkit called RNA Make, the students who are working towards their graduation and are looking for a real-world project, and then the infrastructure component, which is various components, but in this case, mostly the gateway component and the OSG pool of resources. So I'm going to cover each of those individually. We'll start with the science. The goal was to create a science gateway for the RNA Make suite of tools, and this was developed by the Weitzel lab, and he is an assistant professor there at University of Nebraska-Lincoln. RNA Make is basically tools that allow you to model 3D 3D RNA structures. These RNA structures can then be added to various different types of molecules to increase different properties, and I'll talk a little bit more about that in the following slides. But this is a existing toolkit called RNA Make, and it does various different things. It really builds nano machine models. You can see some various different applications here. The first one is a destruction of a disease. So you have a RNA message that goes in, docks with the disease, breaks that disease apart, and then it can be easily and safely removed from the environment. There's a docking example that's down here that's a little bit cut off, it looks like in the slide. And this is for various different drug improvements. You can see the U14 molecule here docking with a protein to adjust that protein in some beneficial way. The third example here may be familiar to those of you who have really watched the mRNA vaccine process. This is where an RNA controls specific proteins within a molecule and determines which proteins are generated or potentially not generated. I want to be clear and transparent here that the Weitzel lab is not working on mRNA vaccines. However, they are working on this. RNA Make can contribute to the future of the way vaccines are both delivered and stored. So one of the main things you can do with these 3D structures, these 3D nanomachines, would be to increase the stability, both of shelf life and then the lifetime within the cell. And one avenue that's mostly used right now is a chemical modification. However, a second option would be to create these strong 3D structures that are generally more stable than doing a chemical modification. So, and again, these modifications increase the stability in various different forms. So the RNAMake tool we found was a good fit for the HTC environment. It has small input-output. It has relatively small memory use. The jobs can be split and stitched back together later, and the runtime seemed relatively ideal for the OSG. So moving from the science to the students, you can see two groups of students here. This is used for a capstone project for undergraduate seniors, and they were from a mix of disciplines, including computer science, computer engineering, and software engineering. And the idea was really to give them a real world project that they could interact with a customer, in this case, the science, and find, gather requirements, look at the existing software, integrate that software into a new environment, and basically increase many of the skills that they will see once they move on beyond the university environment. The group on the left was the 2021 students, Evan, Josh, Dan, Daniel, and Connor. The group on the right, who looks absolutely thrilled to be in this picture, are Kevin, Katie, Trent, Abdullah, Josh, and Peter. They're still working. Hopefully they all will graduate at the end of the semester. And so what we did was cut these down into various tasks. The initial tasks for the first group was to add the HTCondor submission function to the Airavata framework, and then do an initial implementation of that framework and the initial functionality for a gateway implementation. The group in 2021-2022 built on the work of the first set of students and added the additional HTCondor submission functionality and enhanced the gateway even further. So there was not only students working on this, there was some additional effort. As I mentioned earlier, the Exceed Extended Collaborative Support Services provided some staff effort on this when the students were active. They didn't, again, this was student-led, so it wasn't the staff working on it year-round. The staff worked on it when the students needed their help. One note here is that this effort from ECSS will no longer be available at the end of the Exceed project as it transitions into Access. As of now, there's not an obvious mechanism within Access to continue these support services like this. So we'll need to look at that going into future projects. I think the project itself has been successful enough to warrant future iterations. But Aroma, Demuthu, and Dinaka all provided technical assistance, and Derek and myself provided some oversight and institutional support. So if people would like to work along, you can go to this dev.rnamake.scigap.org. Again, this is a development structure, and I have screenshots here, so there's not much that you can do that you won't see here, but you're free to go navigate to that site, request an account, see what you can do, especially if the science is interesting to you. It may be interesting. Again, this is the splash page when you arrive. You can see up in the top right corner, you can create an account or log in, and you have some documentation and contact information. When you log in and start a project, you get basically a web interface that allows you to tune parameters that you may want to submit, name your project for sharing or for identification later. And again, you can slide these bars to tune the various different parameters, the number of scaffolds you want, the number of designs, and a limit on time potentially. And then you have the submission screen. So here you review your parameters, hit submit job. When you hit submit job, this then navigates to a HTCondor job manager, which then finds the OSG pool, and you can monitor through email or on screen the progress and completion. So that's generally the walkthrough of the site, but we found that in bringing together these computer science and computer engineering students with scientists, there were some additional and beneficial unplanned effects. We introduced the SMM Labs Docker containers, which allowed them to distribute Docker containers rather than compiling the C++ code, which RNAMake is made in, and that allows them to run the analysis anywhere, whether that's laptop or cyber infrastructure or cloud. So they have these Docker containers now that they may not have come along nearly at the time if we hadn't integrated both the chemists with the computer science students. They also identified a new molecule protein viewer called GNMOL. This was something that could be integrated into the website for visualization. Previously, they were using a different viewer. This has some additional benefits, but again, comes from computer science. It's computer scientists looking for specifically something they could integrate within the Science Gateway that was probably not on the radar of the chemists developing the tools. So now I'll do a quick introduction to the Airavata Gateway stack, just so you have a reference here. And when I say gateway, I basically mean user interfaces, web-based user interfaces to for researchers and students and educators to provide access to resources. Just checking my time here. Okay. So the Airavata stack has various different layers, the top being the science-centric interfaces. These are web-based interfaces based on Django that allow the interaction with the underlying layers. It uses custom security services based on state-of-the-art industry standards, Apache Airavata data services with managed file transfer based on Node.js. And then we have the execution services, which are based on Apache Helix, and then allowing various different types of resources, including elastic virtual clusters and any place that you can use basically a container infrastructure as the end compute resource. So just an idea here, the portion on the left is the standard Airavata Django portal and the modules that come with it, including the authentication and authorization, the user group management, the data management, and a CMS for contact, including the monitoring and response. And we created some customized RNA, or I should say the students created some customized RNA modules to put in with this. This was CMS content that was directly related to RNA Make, the user interface that was modified to the experience of the chemist laboratory, or the laboratory chemists, and then the various different data models that were necessary for RNA Make. So you can see that they use some of the general modules, but then replace that with some custom content to make this into the RNA Make project. And again, Airavata allows these customization of various different aspects of the stack, or of the framework to allow the individual scientists' needs to be met. So it did leverage quite a bit of cyber infrastructure, as I said, the Exceed resources, including Jetstream, which hosts the portal in the development environment. The OS pool was allocated through Exceed XRAC, and it used effort from the extended collaborative support services. Things are scheduled through HTCondor, through the Glide-in factory for scheduling to OSG nodes. And then we have the federated authentication that allows any university's credentials to authenticate through the portal. This is connected with CI logon. Just a quick look at the workflow, and I won't go over this too in depth here, but you can see that the gateway user is interacting with the applications through experiments. They can then do group and data management. When they execute or submit jobs, this runs through HTCondor out to the HTC research in the resource in this case. The Helix workflow not only allows Condor management, also other schedules to be managed, and then monitors things through emails that are then sent back to the application. So again, the user can monitor things through email or through the gateway interface for alerts when there is job completion or when the results are available. Okay, and of course, with any project, there are some challenges. There was a bit of a learning curve to develop within Airavata for the students coming in, having had mostly academic type projects. There was a learning curve. The consultants here at Indiana worked with the students pretty in depth to mentor them in developing under Airavata. Of course, undergraduates had to be prodded at various different times to continue the work and to move forward. So that was a bit of effort. And then one of the challenges I see upcoming is then continuing this program into what is a successful program into the 2022-2023 academic year. It's most likely, from talking with Derek, that it won't be RNA Make that is tackled, but the general idea of finding a science unit at UNL, integrating a certain number of CS, computer engineering, software engineering type students with them to produce some sort of output is going to be continued. As I said, the effort from the gateway side will have to be determined at a later point, and as we see how things shake out with the access awards and the things working around it. So future work, we have integrated the HTCondor stack into Airavata now, and that allows future implementations in gateways of OS pool resources. In fact, we have, you can see the last point here, we had someone ask immediately when we were talking about this, if CGrid, which is the Science and Engineering Application Grid, and the Delta project, which is another chemistry project, might be near-term targets for integrating HTCondor and OSG resources with existing gateways. We want to integrate side tokens with Custos, which is our authentication module, to provide a finer grained authorization. We'll complete this development for Yasemin Lab and turn that over to them with some minor maintenance, hopefully at the end of the semester, though it may take a little bit of time after that to polish up and make sure it's both sustainable and functional in a way that they need. Of course, the primary goal is to graduate the current set of students who have been working on this now for most of their senior year. And then again, we'll identify some future applications potentially for 2022, 2023. Those may or may not include both gateways, Airavata, OSG, and other things, though I think we have a pretty solid foundation built here, so it would be easy to work within those parameters. So finally, I will acknowledge where the work was funded. And this came from various different NSF funding, including the PATH project and Exceed. Apache Airavata had, it was developed through NSF awards, and again, the Holland Computing Center at the University of Nebraska really sponsored the work, both in identifying the science and then keeping the students on track over time. So I think that's all I have. I will take any questions that anyone may have.
Thanks, Rob. Oh, there's Lauren. Do you want to pick up, Lauren?
Sorry. Yep. I was going to say thank you, Rob. Any questions, raise hand or throw them in the chat. I already see Brian Bockelman, so I'll call on him.
Hey, Rob. First of all, nice to see you here. It's great to hear your voice. It's been a while. So what as one side comment, especially for the Nebraska folks, the senior project program that Nebraska has in its CS department is just really phenomenal, and I really enjoy how they can bring together teams of folks, and they've done some marvelous work in the past. So I guess my question was, whenever I see science gateways, I think of all the wreckage of science gateways past of 10 or 15 years ago, where somebody got really excited about something, and then there's that kind of like decay constant, and then at some point it's like, oh my God, is that thing still on? Do you understand at the Airavata level? I mean, how much investments needed there to kind of get it going? And right, I always am really reluctant to like set up new gateways, because I think of it's fun at the beginning, and then years 2 through 10 it just feels like work. Yeah, do I need to learn Java? Do I need to become an expert with jars or Tomcat or anything like that to do my own?
So yeah, so it's non-trivial. However, the Center for the Cyber Integration Research Center here at IU is hosting many of these, so we can set it up with the CIRC group relatively quickly, get it up and running, port to the various different resources that you may have available. To do this on your own is still a non-trivial amount of effort, right? So somebody going to the GitHub repository for Apache Airavata and setting up the infrastructure is non-trivial. However, we're working hard to host many of these projects. We also have with Jetstream a lot of the general infrastructure set up to host on Jetstream. So I personally wouldn't recommend somebody, like I said, go to the GitHub repository and try to set up an Airavata instance and think that they'll get it working without a significant amount of effort. However, there are options to host this on cloud resources, and along with the maintenance and operations through CIRC. And I see Kevin had a question. I'm sorry, is that Brian? Is that what you needed?
Yeah, absolutely. Thank you.
And I will add on to that of course everything needs refreshing over time, and all software deteriorates over time if left unmaintained. So there is some amount of maintenance that is required to keep things fresh, especially as the infrastructure behind the scenes, behind the gateway, continues to change. However, again, the hosted service is relatively easy to do that type of, or at least we work to do those type of services. So I was trying to read Kevin's question here. So the short answer is yes. There are opportunities to apply Airavata in various different ways. In fact, Airavata has been, I think right now is behind, I think about 40 instances of various different gateways. I mentioned 2 of them that would be interested immediately in having HTCondor submission, and that's the CGRID, the Science and Engineering Application Grid, and Delta, which is a quantum chemistry application. And I would imagine that there will be more. So the CGRID, in fact, in the end, does mostly chemistry. So all of my examples, including the RNA Make right now, are chemistry that are using this. But I think there's definitely room for other places and to use this Airavata stack underneath. In fact, we've all been working hard to submit various different proposals to work with groups who would then move forward on an Airavata stack. So that's a long way of saying yes.
Thanks, Rob. Any other questions? We've got actually a few minutes before the official close of the session, but we can also give people a little more of a break, and there will be plenty of time and discussions to ask more questions of our speakers too.
And let me ask if Derek has anything he might want to add. I feel like I took over that presentation, which I took over the verbal portion, but Derek may have want to comment on anything that he thinks needs focus or I may have missed.
No, I think you did a great job, Rob. I do want to echo what Brian said, that the senior capstone projects in Nebraska are this is a great example of using a senior capstone project to match a computer scientist with domain scientists, and they both benefit. You know, the domain scientists get a benefit from having computer scientists like help them out with their code and help them out with different new technologies, and the computer scientists, the undergraduates, get to learn what it is to be like a domain scientist and to work on a real life project. So I agree that this is a great example.
Thanks, Derek. All right. Well, seeing no more questions or hands, we can close out this session just a few minutes early, give people a little bit more of a break.